So welcome everyone. It's my pleasure to give a talk about building and running an AI-powered product, which I'm going to demonstrate with an own product in progress. But let me introduce myself first. My name is Valentina Halasi, and I'm originally an applied mathematician, and I've been working in Switzerland in the past 7 years in research. I've been researching with AI planning and also computation and neuroscience after I worked in the industry. And I'm currently an AI developer, and I'm lucky to have this as my work, as my passion. I love hacking on projects, sharing experience and knowledge like today. I also love travel and diving, but I'm going to talk about a tech project I've been working on with Max together. And this is a common effort, so at the end you can also ask questions from him as well. Why do we focus on this today? Because it has never been as accessible as today to create AI projects and build a product out of it. Thanks to cloud providers like OpenAI and communities like Hugging Face, and a variety of models make it possible to build stuff without the need of having a team of computer scientists, data scientists, other professionals, expensive computer cluster to own. You can rent it. And everything is accessible to create a great product from it within a short time. But the part of the development is that the technology is evolving so quickly that you have to face some pitfalls during the work, racing with time, with competition. New major breakthroughs are coming every single week, so it's very difficult to stay up to date and to keep your product, your project, state of the art. So while many models are free or very affordable to use, if you want to build a specific product, you will need an own model, and advanced experiments and fine-tuning come with high cost if repeated. So it takes money to find the perfect model for your project. It's crucial to do the research in advance and to find the best tech for your product. And I'm going to show you how we navigated those pitfalls and demonstrate it with one example, which is an application called Storic. And what is it about? Storic is an application for the creation of highly personalized storybooks with AI-generated illustration and text. You can actually write a book about real persons with the help of AI because you can upload photos of the person, and in the background we are fine-tuning different AI models for you, which we can offer you in this app later on to have like a empty book interface, and then you can click together a storybook. We get it printed and ship it to you. So it was incredibly fun working on Storic and also using it. The first version we made was not like how we imagined how we wanted it to be. The pictures were not consistent in it at all, and it took us months to experiment with it. As we worked on Storic, we realized how much joy the results bring, not only to us who create the books, but of course to the children or the persons who receive it. On the picture you can see my nephew, Laurie. He was the first who received this book about him exploring the animals in the forest. So we wanted to build a version with which anyone without technical expertise can create such personalized storybooks. As I said many times, the key is personalization. So we need a model for text generation, and we need a model for text-to-image generation, but not any kind of model, but a model which is the best at personalization. How do we find such models? Luckily, Hugging Face took care of that, because Hugging Face is a community for AI models. It's like a GitHub for AI models, and they created a platform. It's artificial analysis. It provides benchmarking and related information to support you in choosing the right model for your use case. Why is it important? Because different trade-offs exist between different models and providers as such. So it is very important to start with how you intend to use the model as the first step. What are these trade-offs? For example, the model quality, the price, how quickly it can generate output, so the inference speed, the latency, how much you have to wait while inference, context window, how specific instructions you can add to a model, and other dimensions. So we've been using mostly Stable Diffusion, but also Flux. Stable Diffusion is a very popular model for fine-tuning made by Stability AI. And also, Flux is a newer version of it, more complex, and it was actually made by researchers who left Stability AI and founded a new lab, Black Forest Labs. So most text-to-image, most state-of-the-art text-to-image models are based on diffusion. And those models are based in personalization. So diffusion is the technology which is a supervised learning algorithm, and it can be used to create completely new images from noise. So diffusion models use noise to encode an image, and then they use a noise predictor along with a reverse diffusion process to put the image back together. The older version of diffusion models consists of 3 main components, which are all separate neural nets. And the first one is the variational autoencoder. It transfers your data into a latent space. The second neural net is the UNet. This is the neural net which is able to learn to extract the noise from the picture. And the third part is the text encoder, for example, clip. It is able to establish connection between image and text. The newer diffusion models are a bit more complex, but the source was this architecture. This was the Stable Diffusion XL architecture, which is from 2022. So for our specific use case, we need watercolor images, which look like a painting. And we also want to add personalization into the model. So we want to teach the model the user's photos. And there are already various fine-tuned versions of those base models available on the internet as open source models. For example, at civitai.com, you can find for specific use cases, for example, the model which can generate pictures where every object is made out of sunny-side-up eggs. Unfortunately, we didn't find the perfect model which already existed, so we fine-tuned our own model. There are various ways for fine-tuning your model, but the goal of fine-tuning is always to learn a task-specific feature while keeping the general features learned from the pre-trained network. And we take the so-called checkpoint models, which are for example, Flux or Stable Diffusion Excel. And we do some mathematical operations to fine-tune them. And I listed down 4 different fine-tuning techniques. The first one is textual inversion, which is about finding the right text embedding for your feature. This is useful if you are trying to achieve a result which you suspect the model already knows. For example, you could describe that you want to have those watercolor images, and then the model will figure out what could be the right text embedding in the checkpoint model and gives it to you. So you have a unique token now defined for your concept. The second one is Storybooks. It's a very efficient fine-tuning technique, but yeah, I'm going to talk about it later, why we didn't choose that one. So it was developed by Google Research in Boston University, and you can have your model fine-tuned with only 3 to 5 images, but it takes a very intense calculation to fine-tune with Storybooks. The third one is LoRa, or the family of LoRas is called Icarus. And it was developed by Microsoft Research. LoRa means low-rec adaptation, and it's a mathematical technique to reduce the number of parameters that are trained during fine-tuning, and it freezes the weights of the original stable diffusion model or the original checkpoint model if it's not stable diffusion, and adds new layers with rank decomposition weight matrices for training. So it just modifies the unit through matrix decomposition, and it creates a difference to the base model. We chose LoRa and other types of LoRa for our use case because you can achieve impressive results with it, but the training is faster and the resulting model is much smaller than the one created with Storybooks. And this representation shows very well the difference between those fine-tuning techniques. The fourth fine-tuning technique is hypernetworks. So when we are fine-tuning with this method, we are creating a secondary network of new weights predicted at inference. The weights are just attached to the base model. So as I told you, we used LoRa most of the times during experimenting. While Storybooks excels at generating highly accurate and detailed images, LoRa shines in producing artistic and imaginative results. So in case of a storybook, it's a perfect tool. So you don't have to, if you're a developer, you don't have to analyze those techniques and code it yourself, because luckily there are amazing general fine-tuning kits for diffusion models. Simple Tuner and Kohaya are both Python libraries for fine-tuning, and the previously mentioned methods and implemented in them. So first, we wanted to achieve a specific style, like drawn or painted watercolor images where the person is recognizable, but not too realistic, not scary, just a beautiful picture into a children's book. This is the style we wanted to achieve. How did we do that? So first one, we needed, so it was an iterative process. With every deployment, with every new product version, we took the pictures of the old model as base pictures, but in the very beginning, we used Midjourney for generating thousands of pictures according to our own prompts, describing, please create a picture of a deer standing in a forest next to a stream, watercolor illustration, such prompts. And we created thousands of such pictures. High diversity of characters is needed. So we created a long list of prompts with automated generation. After we manually selected approximately 10% of it to only keep the best, which are according to the style we wanted, and we also sorted out those pictures which were a bit weird for some reason. And then we used a custom strip to generate captions with GPT-4o. So after fine-tuning with LoRa, our model is a 50 megabyte big file, and we load it on demand in Replicate from our cloud storage. But I will tell you later on this process. So not the style was the hard part, but the fine-tuning Stable Diffusion or Flux for persons. It was the most challenging part of the development, and it's also every time a person uses Storic, they do fine-tuning actually. So this method had to be very good. We invested a lot of time in experimenting with it. So we were just trying out various combinations of hyperparameters. There is no one universal tactic for optimizing your model and the hyperparameters. It's a long process to find the right ones. There is a trading off between generation speed and image quality. So we were experimenting with a number of model steps as well to find where we can get a lot of marginal speed by sacrificing little to no marginal quality. And by default, the models run at floating point 32 precision on GPUs, but we were quantizing those models, so we wanted to make them run at lower precision. This is how we achieved that the fine-tuning runs a bit faster. This is also very important because since the user is fine-tuning, it has to wait. So fine-tuning had to be quicker than fine-tuning for the style. So in terms of the input, the diversity is obviously must. We are preprocessing the user data and make a quality check, but there is never enough quality check if the user gives the input to your AI model. So that's something where we should definitely invest even more time to optimize. And also, we need different pictures of the users. So it's also planned that we would develop a bit more AI assistance while the user is uploading the pictures. So our AI assistant can see what kind of quality pictures the user is uploading. Even if we put a lot of effort into this part of the development, it's never ending. So every week we try out new methods, new hacks, new tips. Stable Diffusion and Flux both have their shortcomings. So if we, especially in Stable Diffusion, if multiple characters are present on the prompted picture with different attributes, then the result is always a picture where the attributes are melted. So, no, it's called bleeding attributes, not melted. And in terms of Flux, Flux is Flux. I think it's Flux because it's from Germany. Yeah. So it's a so-called distilled model what we are using. So there are 3 types of Flux. It's Flux Pro, which is the smartest model, the biggest model. And this one is very expensive to fine-tune in our case because we cannot let it run for hours. It has to be minutes. And Flux has a Flux Dev, and I mean, there is Flux Dev and Flux Schnell, and they are so-called distilled models. So they have learned from the Flux Pro model. So this is why they are very hard to fine-tune. And those are shortcomings we are fighting with, but we luckily always have new ideas and improvements in the model, so it's a never-ending process. So when we have ready-to-use models, we just have to use the Diffuser's Python library. It's from Hugging Face. It's an open source implementation of diffusion models. Easy to use. We can upload our own model and we can generate pictures with it with this short code. So I mentioned earlier replicate. For experimenting, we are using Google Colab, but in production, we use replicate. So we load our models on demand in replicate from our cloud storage. And replicate is great because you have a free choice of hardware there. The pricing is flexible, however, is expensive compared to other providers. So we also have to optimize this, but right now we are using replicate in production because it has many good points, like it has an API, so you can use your model in your own web application. It handles queuing, so it helps to scale access the model. So when you have multiple customers, multiple people are using the app, in the same time, it deals with it. So Replicate offers also open models and ready-for-use models, but it offers the possibility to deploy your own models, like in our case. But as I said, it's expensive. So for inference, it is affordable. So when generating the pictures, but for training, we are exploring new options. I didn't tell much about text generation in terms of Storic because it's the less challenging part. Generating images is much more extensive and more work. But we are using LangChain. With it, we can put LLMs into our application. So using LLMs in real-world solutions requires engineering work, but with LangChain, we can save this time. Because LangChain is representing common steps and concepts necessary for working with large language models. It has modular components defined, and they serve as the building blocks of your application. In terms of which models we use, well, for prompt preprocessing, we are using GPT 3.5. But the text generation, the actual stories were generated with a model which is more capable for this task. It's a Cloud 3 Sonnet. And it's a good thing that you can train multiple models in LangChain. So Storic is not an app for mobile phones or tablets. It's a web application, so you can access it with any type of device which has a browser. We developed it with Nuxt, and it's making the process efficient, and it's written in TypeScript. Actually, Max did this because he's a very experienced web developer, unlike me. And we use Superbase as backend service and as database as well. We use it for authentication and also for object storage. It's a very safe option. It's a very safe option, which is very important for us because we are dealing with sensitive data. We can say the customers are uploading pictures of their children, and Superbase is a very safe option. For implementing payments, we use Stripe. That's the quickest way to add payment option to your website. So according to our expertise and research, this tech made it possible to build such an application in the shortest time, most efficient time, and I can highly recommend them to you. So now we've seen the tech behind it, but how does Storic actually work? I created a short demo, which I hope it's gonna be running. Yes. So, as I said, we need 8 pictures of the person. The user has here has to upload it, and here the user can actually create a character. So you can add the photos at persons, and at characters you can add additional information of the person. For example, what kind of clothing you wish that the person is wearing in the book. And after, you can go to books. It's an empty book so far, the book wizard. You can pick your characters. Now we only define one. And then you can pick the language. It's available in 190 languages. And then you have to pick or give a general idea of your book. So I say the prompt is, the story should be set in the space. I would want to send Laurie to space. So the middle one, Laurie builds a spaceship out of cardboard and imagination, embarking on a journey through the solar system, learning fun facts about each planet he visits. That sounds great. I want to teach Laurie something like that, so I'm going to choose that one. Here I give the title. It's suggesting a day Laurie discovered a secret word. Perfect. So we have the empty book. Now we have availability to generate a cover image. Laurie in the space is the prompt. There he goes. And now we are generating some text. So the book wizard, the AI assistant can generate ideas for you, which you can either pick or you can either give your own idea, and the AI assistant will write the page accordingly. I'm writing the story should start in Laurie's garden. Right page. Laurie was playing in his garden on a sunny afternoon. Blah, blah. Laurie sat up and looked around his garden. He spotted some empty cardboard boxes that his dad had left out for recycling. Suddenly, an idea popped into his head. I know, he exclaimed. I will build my own spaceship and go on an adventure through the solar system. Great, Laurie. So let's illustrate this. A new page, a picture icon, and we're generating. Laurie is the unique prompt. You teach the model, unique token you teach a model at fine-tuning. And it's very important that you use @Laurie in the prompt. Laurie in his garden playing with a cardboard box. There he is. All right, so let's generate a bit more complex picture, or at least a bit more complex prompt. Let's see how the model reacts to it. Laurie floating in space, holding a sign, build stuff. Well, first, almost there. The text is not right. The next one, he has 4 hands, yeah. Next one, almost there. The text is wrong again. Now his feet is a bit weird. Now the text is bad again. But this one is great. So it takes a few iterations to find to get the perfect picture. This time it took like 6 tries, or approximately. So if you give a bit more complex prompt or something with text, it's gonna take more time. But there could be funny results as well. So maybe not the one with more hands, but if it puts a cute animal on the picture, even if you didn't ask, that happens sometimes, but it's just fun working with it. So we wrote 3 pages of the book, and this is how it goes further. And when you finish the book, we just get it printed and ship it to you. So we had already beta testing behind us this year, and we have some learnings from it. So first of all, which I already mentioned, we are fine-tuning models every time the user orders a book. So the user uploads the pictures. We don't know what kind of pictures, and we don't know what kind of quality. So sometimes they do upload bad quality pictures, and they upload the same picture 8 times, which is obviously not going to bring the results we try to achieve. So AI-powered guidance is needed, and we have to invest much more time into this question point, because it's very important that if we have a great model, which we have been working on a lot, then it's not going to be ruined by bad data. And the second point is latency. So the time you have to wait for generating the picture and the text. I didn't show you the real speed. I speeded up a video a bit, but you have to wait approximately 6 to 7, even 10 seconds to generate a picture. It's not due to the fine-tuning. It's already in the main model the same. So very extensive calculations are running behind the model, so it's understandable. But for a person who is used to the very quickly running screen and scrolling, it's a lot of time, 6 seconds. So the user will lose its motivation to go further and finish the book, especially if it's like 20 pages long. Maybe developers are used to focus on such tasks, but not everyone is like you or we are. So the user is losing its motivation while setting together the book. So the solution we have in mind for this to actually generate the complete book in advance, right after the fine-tuning. So we are working on an AI agent system which has various agents, and each one is responsible for a single task, like generating the prompts for the pictures, taking care of the story, that it's actually that it follows the prompt of the user, but also that it belongs to the generating images, that it's just a great book altogether. So we are using Crew AI. It's a cutting-edge Python framework for orchestrating role-playing autonomous AI agents. And it empowers agents to work together seamlessly. It's very easy to use. So we are hoping to achieve better user experience with such initialization of the book. But the user will still have the availability, still have the option to edit the book the way I showed before. So the takeaways of today's talk are that it's more accessible than ever to build AI products, and I encourage you to do so. But if you do so, constantly follow the development of new models and adapt your product according to it. It's going to be stressful, but if you enjoy it, it's fun. And make your life easier with using services like Replicate, and make sure to have alternatives ready, because you never know, maybe Replicate raises its price from one day to another, and you finally have no profit to make. With the new prices, and you cannot afford to experiment for months with the new service. So it's very important to always have an alternative option. So when building with LLMs, I recommend you to use LangChain. And if you think about enhancing your product development, you have to put aside your plans and ideas, because it doesn't matter if the user doesn't use the product happily. So I recommend to focus on the reaction of the early adopters and actually monitor how they react on your product, and implement the changes needed according to the user needs, and not according to the technological improvements, because it's more important to please the user. Thank you so much for your attention, and feel free to try Storic. This is my LinkedIn. This is Storic. We have free shipping right now. We are shipping to you, I guess. We are shipping most of Europe, and also starting to ship to North America. So if you have any questions, you can reach me on valentina@storic.ai. Thank you.